Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss top 30 questions in Moving Charges and Magnetism. Moving Charges and Magnetism is high weightage chapter for COMEDK 2024 exam. Okay, so they will ask minimum 4 questions from this chapter. Sorry, they will ask question 3 to 4 questions. Okay, they will ask 3 to 4 questions from this chapter. Okay, so if you are able to solve these 30 questions, definitely you will be able to counter these kind of questions in the exam. Okay, yeah. Question number 1. A very long conductor carries a current of 1 ampere. The magnetic field at point whose distance is 0.1 meter from end of the conductor is. Okay, so this is the very long conductor. Okay, so it carries a current 1 ampere. Carries a current 1 ampere. The magnetic field at point, okay, point whose distance 0.1 meter. Whose distance 0.1 meter. Okay, 0.1 meter from one end of the conductor. Okay, from one end of the conductor. Okay, sorry, here the diagram is wrong, right? So here this is the very long conductor. Okay, from one end of the point. Okay, so this is the point where we need to find the magnetic field. Here the distance is 0.1 meter. I equal to 1 ampere. Okay, so this is semi-infinite wire, right? So what is the magnetic field due to the semi-infinite wire? At point P, the magnetic field due to the semi-infinite wire B is equal to mu naught I divided by 4 pi r into sine theta 1 plus sine theta 2. So what is the value of theta 1? Theta 1 is 90 degree and theta 2 is 180 degree, right? Sorry, theta 2 is 0 degree, right? So sine 0 is 0, sine theta 1 is sine 90 degree, that is 1. So B equal to mu naught I divided by 4 pi r. So what is the value of r? 0.1 meter. What is the value of mu naught by 4 pi? 10 to the power minus 7. What is the value of I? 1 ampere. So B equal to 10 to the power minus 7 into I is 1 ampere divided by R is 0.1. So B equal to 10 to the power minus 6 Tesla. B equal to 10 to the power minus 6 Tesla. So the correct option is C. Okay, correct option is C. Yeah. Question number 2. A voltmeter which can measure 2 volt is constructed by using a galvanometer of resistance 12 ohm. Okay, so the resistance of the galvanometer is 12 ohm. Here this is the voltmeter, right? It measures 2 volt. That is the voltage across the galvanometer plus voltage across the R is equal to 2 volt, right? Voltage across the galvanometer plus voltage across the R is equal to 2. And that produces maximum deflection for the current of 2 milliampere. Then the resistance R is, okay, it produces maximum deflection for the current of 2 milliampere, right? So current flowing through the circuit is 2 milliampere, isn't it? So apply KVL, right? Or okay, sorry, here voltage across galvanometer is equal to voltage, plus voltage across the resistance is equal to 2 volt, right? So voltage across the galvanometer, that is I into G, plus voltage across the resistance, that is I into R, is equal to 2 volt, right? Is equal to 2 volt. So what is the value of I? 2 milliampere. So 2 into 10 to the power minus 3 into G, right? So what is the value of G? 12 volt. Sorry, 12 ohm. Okay, 12 ohm plus I is 12 milliampere. Sorry, 2 milliampere. I is 2 milliampere. Milliampere into R. We need to find the value of R. So which is equal to 2 volt. So now 2 into 12 is 24, right? So now 2 into 10 to, okay, here take 2 into 10 to the power minus 3 as common. 2 into 10 to the power minus 3 into 12 plus R, which is equal to 2, right? So now 2 will get cancelled. Now 12 plus R is equal to 10 to the power 3, that is 1000. So R equal to 10 to the power 3, that is 1000. Okay, I will write 1000 here. 1000 minus 12. So the value of R is equal to 988 ohm. The correct option is B.
Hello students, Diksha and Vedantu has launched a COMEDK 2024 mock test series in collaboration. So in this series you will be getting 10 mock tests. So there will be 8 full length mock tests and 2 part test mock tests. Now what are the features? You can see there will be 8 full tests and 2 part tests, and this will be exactly in the COMEDK exam pattern. Next, all the exams will be in the CBT mode, and then you have the freedom to retake the test multiple times. Okay, you can write the test multiple times, and then you have like all the questions are in the latter syllabus of COMEDK, so deleted topics will not be there, and you will get a comprehensive analysis report after each test once you submit the mock test. Okay. So this mock test series is available at the price of 499 rupees. So please join it, enroll it, and the link is there in the description section.
Question number 3. A straight wire of length 2 meter carries a current of 10 ampere. Okay, straight wire. The length of the straight wire is 2 meter. Okay, it carries a current of 10 ampere. If this wire is placed in a uniform magnetic field of 0.15 Tesla. Okay, so the current carrying wire of length 2 meter is placed in a uniform magnetic field of 0.15 Tesla, right? The current in the wire is 10 ampere, making an angle 45 degree with the magnetic field. The applied force on the wire will be the simple one, right? The direct question. So force due to magnetic field on the wire will, current carrying wire will be F equal to I into L into B into sin theta. F equal to ILB sin theta, right? So what is the value of I? 10 ampere. What is the value of L? 2 meter. What is the value of B? 0.15 Tesla, right? So what is the value of sin theta? Sin 45 degrees 1 by root 2. So F equal to, solve this. Okay, so here I is 10 into 2 into B, right? B is 0.15 Tesla into 1 by root 2. So F equal to 3 divided by root 2 Newton. Yeah, next question. Question number 4. In an equilateral triangle of side 4.5 into 10 to the power minus 2 meter. Okay, so every side has length 4.5 into 10 to the power minus 2 meter, right? So 1 ampere current is flowing. Find magnitude of B at its centroid. We need to find magnitude of the magnetic field at its centroid, isn't it? Okay, we need to find magnitude of the B, right? Yeah. So now let us find the current due to one wire. Okay, so there are 3 wires, right? It is arranged in equilateral triangle. First wire, second wire, and third wire, right? So let us find magnetic field at the centroid of the equilateral triangle due to the first wire. Okay, so what is the magnetic field due to the straight wire? Magnetic field due to the straight wire is B equal to mu naught I divided by 4 pi r into sin theta 1 plus sin theta 2. Okay, here each side has length 4.5 into 10 to the power minus 2 meter, right? Okay, so now magnetic field due to the first wire B1 is equal to mu naught into I divided by 4 pi into r. Here we need to find the distance r, this one, right? Isn't it? So what is this distance? here this distance is L. Let's say the distance AB is L. Okay, so now AD will be L by 2, right? AD will be L divided by 2. Here the angle is 30 degree, right? The angle is 30 degree. So it is equilateral triangle. If you draw perpendicular bisector, so this angle will be 30 degree, right? If this angle is 30 degree, this angle will be 60 degree, right? So what about this length, right? So this length will be here x divided by, okay. So what about the hypotenuse? Hypotenuse will be L by 2 divided by x equal to cos 30 degree, that is root 3 by 2. So now 1 by 2 will get cancelled. So x equal to L divided by root 3, right? X equal to L by root 3, isn't it? So here hypotenuse is L by root 3, right? Hypotenuse is L by root 3. So what about this one, right? Here the angle is 60 degree, okay. So now L, here L by root 3 is x, right? Okay. So now this is x dash divided by L divided by root 3 is equal to cos 30 degree, that is 1 by 2, right? Sorry, cos 60 degree, that is 1 by 2. Now L dash is equal to L divided by 2 into root 3. Okay. So now this distance is L divided by 2 into root 3, right? L divided by 2 into root 3. Okay. So now here R is L dash, right? So now L divided by 2 into root 3. Okay. So which into sine of theta 1 plus sine of theta 2. Here theta 1 is 60 degree, theta 2 is also 60 degree. So sine 60 degree plus sine 60 degree is 2 times sine 60 degree, that is 2 times root 3 by 2 is root 3. Okay. So this is the magnetic field due to the one wire, right? So there are 3 wires. Now multiply it into 3. Now net magnetic field at its centroid, at the centroid of the equilateral triangle is 3 times B1. Okay. Now B net is equal to here root 3 into root 3 is 3, right? So now 3 into mu naught by 4 pi. Mu naught by 4 pi is 10 to the power minus 7 into I. I is, what is the value of I? I is 1 ampere, right? 1 divided by L, right? Mu naught by 4 pi is done, right? L by 2, right? L by 2. So L by 2, 4.5, right? 4.5 is 9 by 2. 9 by 2 by 2, right? So that is 9 by 4. 9 by 4. So 9 will get cancelled. So net magnetic field at the center, okay, net magnetic field at the center is equal to 4 into 10 to the power minus 7 Tesla. 4 into 10 to the power minus 7 Tesla. Okay. Okay, here into 10 to the power minus 2 is there, right? So this will be 10 to the power minus 5. Sorry, here this will be 10 to the power minus 5. 10 to the power minus 5. Sorry, I have missed 10 to the power minus 2. So into 10 to the power minus 2 is there. So this is 10 to the power minus 7 by 10 to the power minus 2 is 10 to the power minus 5, right? So this is the net magnetic field at the centroid of the equilateral triangle. Okay. The correct option is A. Question number 5. A circular coil of turns, 100 turns, circular coil of 100 turns, that is the value of n equal to 100 and effective diameter of 20 centimeter. Okay, effective diameter of 20 centimeter. So what about the radius? Radius will be 10 centimeter, right? Radius will be 10 centimeter. Carries a current of 0.5 ampere. The value of I equal to 0.5. 0.5 ampere. It is to be turned in a magnetic field B equal to 2 Tesla from position in which theta equal to 0, theta equals 0 to theta equals 180 degree. The work required in this process. Okay, so here circular coil turned in a magnetic field of 2 Tesla from the position theta equal to 0 degree to theta equal to 180 degree. So how much work is required to turn the circular coil, right? So now work is equal to the work required to turn the coil, W is equal to minus M dot B. So what is M vector? Magnetic moment. What is B vector? Magnetic field, right? So now W is equal to minus MB cos theta. W equal to minus MB cos theta, right? So here work done is change in potential energy, right? Final potential energy minus initial potential energy. So now work done is equal to, yeah, it moved from 0 to 180 degree, right? 0 to 180 degree. So now minus M. M is magnetic moment. Magnetic moment is N into I into A, right? N into I into A into B. B is magnetic field into cos theta, right? Cos theta, right? So now W is equal to here minus of 100 into I. I is here, what is the value of I? 0.5 ampere, that is 1 by 2 into A, right? The diameter is given, right? So what about the area? Area is 10 centimeter. Radius is 10 centimeter. So area will be pi into r square, right? So area will be pi into r square is 10 into 10 to the power minus 2 whole square, that is 100 into 10 to the power minus 4. 100 into 10 to the power minus 4 is 10 to the power minus 2 meter square. Okay, so now pi into 10 to the power minus 2 into beta, B is 2 Tesla into final minus initial, right? So final minus initial, final position minus initial position, that is cos 180 degree minus cos 0 degree. So now W is equal to, here 2 will get cancelled and 10 to the power minus 2, 100 will get cancelled. Cos 180 degree is minus 1, cos 0 degree is 1. So minus 1 is minus 2, minus into minus plus. So 2 pi joules. The correct option is B. Okay. Question number 6. Two identical wires A and B have the same length L and carry the same current I. Okay, two identical wires A and B. Okay, so both have the same length and both carries the same value of the current, that is I. Wire A is bent into the circle of radius R. Okay, wire A is bent into the circle of radius R. Okay, let's say, okay, here the length of the wire is L, right? So then this is equal to the circumference of the circular wire, that is 2 pi R. 2 pi capital R. So what is the value of R? R equal to L divided by 2 pi. Okay. And wire B is bent into form of a square of side A. Okay, wire B is bent into a form of side A, right? If B1, okay, each side has the length L by 4, right? Okay, so A equal to L by 4. A equal to L by 4. If B1 and B2 are the values of the magnetic field induction at the center of the circle and the center of the square A. So now what is the magnetic field due to the circular coil at its center? B equal to, this is B1, right? Isn't it? So if B1 and B2 are the magnetic field induction at the center of the circle and the center of the square. So B1 equal to mu naught I divided by 2R. Okay, 2R. R is capital. Let us find B2. Okay, so it's square loop, right? Magnetic field at the center of the square loop. Here the side is A. Okay. So what about this distance? A by 2, right? So this will also be A by 2 and A by 2, right? So magnetic field at the center due to the one wire is mu naught I, okay? So B2, okay, mu naught I divided by 4 pi into, so what about this angle? Here this angle is 45 degree, okay, 45 degree. So this angle will also be 45 degree, right? So 4 pi into A by 2 into sine 45 degree plus sine 45 degree, that is 2 by root 2. 2 by root 2 is root 2, right? So magnetic field at the center of the square loop, right? So there are 4 sides. So 4 into here 2 root 2 into mu naught I divided by pi into A, right? 4 pi into A. 4 into 2 is 8, okay, 8 into root 2 mu naught I divided by 4 pi into A. So now B2 is equal to 8 into root 2 into mu naught I divided by 4 pi A, right? 4 pi A. A is L by 4, right? So this will be A, okay. So now here we need to find the ratio of B1 and B2. So B1 divided by B2 is equal to, anyway mu naught I will get cancelled. So 1 divided by 2 into R whole divided by 8 into root 2 divided by 8 into root 2 divided by, here, okay, mu naught I got cancelled, right? 8 into root 2 divided by 4 pi into A, right? So what is A? A is L by 4, right? I can write A as L by 4, right? Here it is L by 4, okay. I will write here. So B1 divided by B2 is equal to 1 divided by 2R. R is L divided by 2 pi, right? L divided by 2 pi. So 2 into R, R is L divided by 2 pi into 4 pi A. So 4 pi A is L by 4 divided by L by 4 divided by 8 into root 2, right? 8 into root 2, isn't it? So then B1 divided by B2 is equal to, so 2 will get cancelled. Then pi will go to the numerator. So it is pi square, right? And then 4 will get cancelled. So pi square divided by, okay, L will also get cancelled. So pi square divided by 8 into root 2. Pi square divided by 8 into root 2. So this is the value of B1 by B2, okay. So this is the value. The correct option is B. Question number 7. A proton, a deuteron and an alpha particle. Okay, proton is P, deuteron is H21 and an alpha particle. This is alpha particle. Okay, alpha particle is nothing but helium atom, right? So proton is nothing but hydrogen, okay. Having the same kinetic energy are moving in a circular trajectories in a constant magnetic field of magnetic field. Okay, magnetic field is constant. If and kinetic energies of the 3 atoms or 3 particles is also constant. Sorry, same, right? If RP, RD and R alpha denote respectively the radii of the trajectories of these particles, then okay, we need to find the relationship between RP, R alpha and RD, right? Okay, let us compare the radii of curvature of the R alpha and RP. So we know that when charged particle enters into a uniform magnetic field, what happens? It takes circular path, right? Enters into a uniform magnetic field, okay. The motion of the particle must be perpendicular to the magnetic field. Then only it takes circular path, right? So the radius of the circular path R is equal to radius of the circular path r equal to m into v divided by q into b, right? So what is m into v? Momentum, right? So we know the relationship between momentum and kinetic energy. So momentum equal to root of 2m into kinetic energy, right? So r equal to, I can write mv as root of 2mk divided by qb, right? Root of 2mk divided by qb. So now radius of the alpha particle is equal to root of 2 into m alpha, mass of the alpha particle. Mass of the alpha particle is 4 times mass of the proton, right? So I can write mp, 4mp, okay, 4mp into k divided by qb, right? Q is charge of the alpha particle, which is equal to 2 times charge of the proton into b. So now rp is equal to, that is radius of the proton, 2mp into k divided by qp into b. So now take the ratio of r alpha and rp. Okay, take the ratio of r alpha and rp, you will get 1, which is equal to 1. From this I can conclude that r alpha, the radius of the alpha particle, is same as the radius of the proton. Okay, radius of the, sorry, not radius of the alpha particle, radius of the circular path taken by the alpha particle is same as radius of the circular path taken by the proton. Okay, r alpha equal to rp, right? Okay, so anyway option A is correct. Okay, let's check whether this condition is correct or not. Oh, okay, sorry, this relation is correct or not. Now rd, right? Rd, that is radius of the circular path taken by the deuteron. Rd is equal to root of 2 times mass of the deuteron is equal to 2 times mass of the proton. So 2 times mass of the proton into k divided by charge of the deuteron is equal to charge of the deuteron is same as charge of the proton, right? That is qp into b. So now compare rd with r alpha and rp. Okay, so then rd is greater than rp and r alpha. Okay, so rp equal to r alpha. The correct option is A. Okay, correct option is A. Understood? Yeah. Question number 8. Two circular coils 1 and 2 are made from the same wire, but the radius of the first coil is twice that of the second coil. What potential difference ratio should be applied across them so that magnetic field at their center is same? So what is the magnetic field due to the circular coil at its center? B equal to mu naught I divided by 2r, right? Radius of the first coil is equal to 2 times radius of the second coil, right? We need to find the potential difference across the two coils so that their magnetic field at their center is same. Okay, that is B1 is equal to B2, right? B1 is mu naught I1 divided by 2 R1, which is equal to B2. B2 is mu naught I2 divided by 2 R2. Now mu naught by 2 will get cancelled. So I1 by I2 is equal to R1 by R2. So we know that Ohm's law V equal to I into R, right? V equal to I into R. I into capital R. I into capital R. Okay. So now V1 divided by V2 is equal to I1 divided by I2 into R1 by R2. Why it is R1 by R2? Because the length of the coil is different. First coil and second coil is different, right? The radius is different, that is the length is different, isn't it? So therefore resistance will also be different. Even though two coils made up of same material, their radius is different, right? So that's why the resistance is also different. Resistance is also different. So now V1 divided by V2 is equal to I1 divided by I2, right? I1 divided by I2 into, we know that R is directly proportional to R is equal to L divided by A into rho, right? R is equal to L by A into rho. L by A into rho, right? So now rho is same for both, right? And area of cross section of the wire is also same for both, but the length is different, isn't it? The length is different, so it is L1 divided by L2. L1 divided by L2. So now V1 divided by V2 is equal to L is the length of the wire. So length of the wire of the first coil, L1 equal to 2 pi R1, okay, and L2 equal to 2 pi R2. L2 equal to 2 pi R2. R1 is 2 times R2, right? So L1 equal to 2 pi into 2 times R2. Okay. So now L1 is L1 by L2, 2 pi will get cancelled. Okay. I1 divided by I2 is R1 by R2. Okay. R1 divided by R2 into here 2 pi will get cancelled, right? So this will also be R1 divided by R2. R1 is 2 times R2. Okay. Substitute the value of R1 or expression of R1, we will get V1 divided by V2 as 4. V1 by V2 as 4. Okay, so this is the ratio, potential difference ratio should be applied across them so that the magnetic field at their centers is same. The correct option is C. Question number 9. 4 conductors carrying 2 ampere of current into or out of the page. Okay, let us consider into the page as negative, okay, and out of the page as positive, are shown in the diagram. A path C is indicated for the line integral integration of B vector dot ds vector. Okay, B vector dot ds vector. ds vector is your integration of this loop, right? Integration of ds vector is the length of this loop. Okay, find the value of the integral for this path C is. Okay, we need to find the integral for the path C. So this is the, okay, let's apply Ampere's circuital law. Okay, Ampere's circuit law, circuital law. So now integration of B dot ds is equal to mu naught into I enclosed, right? Mu naught into I enclosed. Let us find the total current inside this loop. So what is the total current inside the loop? Minus 2 ampere, minus 2 ampere, plus 2 ampere, which is equal to minus 2 ampere, right? So now integration of B dot ds is equal to minus 2 times mu naught. The correct option is C. Okay, correct option is C. Question number 10. Sensitivity of a moving coil galvanometer is S. That is S equal to G divided by N minus 1. N is the range of the galvanometer, right? Isn't it? If a shunt of 1 by 8th of the resistance of galvanometer is connected to moving coil galvanometer, that is S is also equal to G by 8, its sensitivity becomes, so G by 8 is equal to G divided by N minus 1, so N equal to 9. So sensitivity is equal to G divided by, sorry, the new sensitivity S dash is equal to S divided by 9, right? S dash is equal to here S divided by 9, isn't it? Okay, S divided by 9. So the correct option is here C. Okay, S by 9. Question number 11. A 100 turn closely wound circular coil of radius 10 centimeter. Okay, 100 turn closely wound circular coil of radius 10 centimeter. So R equal to 10 centimeter and N equal to 100. Carries a current of 3.2 ampere. The magnetic moment of the coil is approximately, okay, magnetic moment of the coil M equal to N into I into A, N into I into A, right? Here M equal to N is 100, I is 3.2, A is area of the circular coil, that is pi into R square, right? R square is 10 to the power minus 2 meter squared. So pi is 22/7. So m equal to 100 into 3.2 into 22/7 into 10 to the power minus 2, right? So then solve this, okay, you will get 10 ampere per meter square. Sorry, 10 ampere meter square. The correct option is B. Okay. So this is approximately equal to point. So let's multiply 10. Okay, multiply and divided by 10. So this is approximately equal to 10, right? So then, yeah, that's it. Solved. Sorry, this is approximately equal to 5, right? So then approximately equal to 10. You will get the value approximately equal to 10 ampere meter square. Question number 12. An electron moves with the speed of 2 into 10 to the power 5 meter per second along the positive x direction. Okay, it moves along the positive x direction. Okay, so this is the x direction, moves along the positive x direction in a magnetic field of B vector equal to I cap minus 4j cap minus 3k cap. Okay, so here V is equal to, V vector is equal to 2 into 10 to the power 5 meter per second. What is the direction? I cap, right? And magnetic field vector is also given, right? The magnitude of the force in Newton experienced by the electron. We need to find force experienced by the electron, right? Okay, so now we know that the magnetic field due to the the force acting on the charged particle or moving charged particle due to the magnetic field is F equal to, or F vector is equal to Q into V cross B. Q into V cross B. Okay, so now F vector, we need to find the magnitude of the F vector, right? Let us find F vector. F vector is equal to Q into V is 2 into 10 to the power 5 I cap cross B vector will be I cap minus 4 J cap minus 3k cap, right? So now we know that I cap cross I cap is 0, right? And then J cap cross, I cap cross J cap, I cap cross J cap is K cap. So minus is there, right? So minus K cap. Okay, so now F vector is equal to Q into 2 into 10 to the power 5 into here 0 minus 4k cap. Okay, minus 4k cap, and then I cap cross k cap is minus j cap. So minus into minus plus. So plus 3k cap, right? Okay, so now plus 3j cap, plus 3j cap, 3j cap. Okay, 3j cap. So now F vector is equal to Q is 1.6 into 10 to the power minus 19, right? 1.6 into 10 to the power minus 19. So 1.6 into 10 to the power minus 19 into 2 into 10 to the power 5 into 3j cap plus 4k cap. So now solve this, okay, you will get the magnitude of the F as 1.6 into 10 to the power minus 13. 1.6 into 10 to the power minus 13. Okay. So anyway, if you take the magnitude of 3j cap plus 4k cap is 5, right? 5 into 2 is 10. 10 into 10 to the power 5 is 10 to the power 6. 10 to the power 6 into 10 to the power minus 19 is 10 to the power minus 13. Okay. The correct option is C. Understood? Yeah. So solve this. Next question, question number 13. A horizontal overhead power line carries a current of 90 ampere east to west direction. Okay, so this is east to west direction. Current is 90 ampere. What is the magnitude of the direction of the magnetic field due to the current 1.5 meter below the wire? Okay, due to the current 1.5 meter below the wire, that is here. This is the board, right? Okay, the wire is kept along the board. Okay, so here the backward or backside of the board is below the wire and front side of the board is above the wire. Okay, so now backside of the board is below the wire, front side of the board is above the wire. Here the direction will be north, south, east and west. So we need to find the magnetic field due to the wire, okay, due to the below the wire, okay, in which direction the magnetic field is acting on. Okay, so apply right hand thumb rule. Okay, right hand thumb rule, the magnetic field is magnetic field below the wire is towards south, isn't it? So it is towards south. So anyway, all of them are wrong. So the correct option is A, right? B, C, D are wrong. The correct option is A. Okay, let's find the value of the magnetic field. Here the magnetic field B is equal to mu naught I divided by 2 pi r, right? 2 pi r. 2 pi r. So B equal to mu naught divided by 4 pi. Sorry, mu naught divided by 4 pi is 10 to the power minus 7. So mu naught divided by 2 pi is 2 into 10 to the power minus 7 into I, that is 90 ampere, divided by R 1.5. So this is 60. Okay, 60 into 2 is 120. So B equal to 1.2 into 10 to the power minus 5 Tesla. So this is the value of the magnetic field and the direction is towards south. Towards south. Okay. So the correct option is A. Understood? Yeah. Question number 14. A moving coil galvanometer has 28 turns and area of coil is 4 into 10 to the power minus 2 meter square. If the magnetic field is 0.2 Tesla, then the increase the sensitivity by 25% without changing the area, and field of the number of turns should be changed to. Okay, sensitivity of the galvanometer increased by 25%, right? So that is new sensitivity H dash is equal to 1.25, right? 1.25. We know that sensitivity of the galvanometer is directly proportional to the number of turns, right? Number of turns. S equal to NAB by C, right? So S is directly proportional to N. So now H dash divided by S is equal to N dash divided by N, right? N dash divided by N. N dash divided by N. So now N dash is equal to H dash by S is 1.25 into 28. Okay, so the value of N dash is equal to 35. 35. The correct option is B. Okay, yeah. Question number 15. The particle that cannot be accelerated by the cyclotron is, okay, they have given proton, alpha particle, electron and deuteron nucleus. So particle, here the electron cannot be accelerated through the cyclotron, right? So why? Because the mass of the electron is much lesser compared to mass of the proton, mass of the alpha particle, mass of the deuteron. Okay. Okay. If the mass of the particle is very less, then this particle, that is electron, needs very small amount of energy to accelerate, right? To get the acceleration, isn't it? So if you put the electron in the cyclotron by the minimum amount of energy, so electron get accelerated, right? Isn't it? Electron get accelerated, isn't it? So here the frequency of the electron, right? The frequency of the electron, because of that, the frequency of the electron does not match the frequency of this oscillator, right? Frequency of the electron does not match with the frequency of the oscillator. Okay, so that's why we cannot accelerate. So we cannot accelerate the electron through the cyclotron, isn't it? So the correct option is C. Question number 16. In the following circuit, the resistance of the ammeter is 2 ohm. Okay, resistance of the ammeter is 2 ohm and the resistance of the voltmeter is 30,000. Okay, so resistance of the voltmeter is 30 kilo ohm. That is definitely the current will not go through the voltmeter. Okay, definitely it will go through the resistance and ammeter. What is the value of the resistance R when the ammeter reads 0.1 ampere? Okay, current pass through the voltmeter, it is very minimal. Okay, yeah, ammeter reads 0.1 ampere and the voltmeter reads 10 volt. When the ammeter reads, okay, we need to find what is the value of resistance R when the ammeter reads 0.1 ampere and the voltmeter reads 10 volt. Okay, here voltmeter reads 10 volt, right? So that is a potential difference across R plus potential difference across ammeter must be equal to 10 volt, right? Because voltmeter is connected in parallel with the R and A, right? That is resistance and ammeter. So therefore, the potential difference across R and A must be equal to the 10 volt, right? So 10 volt is equal to 10 volt is equal to, here the potential difference across R, right? Potential difference across R is here I into R. I is 0.1 into the value of R. The value of R is here. Okay, we need to find the value of R, right? We need to find the value of R plus here the resistance of the ammeter is 2 ohm. So 2 into 0.1, right? 0.1 ampere. So these two are in series, right? So current through the R is same as current through the ammeter. So now 10 equal to, take 0.1 as common, then take 0.1 to the other side. Okay, so this will be 10 equal to R plus 2. So 10 into 10 is 100, right? So R equal to 100 minus 2 is 98 ohm. The correct option is B. Okay, yeah. Question number 17. The magnetic force acting on a charged particle of charge minus 2 microcoulomb, that is Q equal to minus 2 microcoulomb, in a magnetic field of 2 Tesla acting in y direction when the particle velocity is 2 I cap plus 3 j cap into 10 to the power 6 meter per second. So we have solved these kind of question, right? I will do it quickly. So F vector is equal to Q into V cross B, right? So this is the magnetic force acting on the charged particle when it is moving in a magnetic field, uniform magnetic field. Okay. So now substitute the values. F vector is equal to minus 2 microcoulomb into V vector is 2 I cap plus, plus 3 j cap into 10 to the power minus 6, 10 to the power 6 cross B vector is 2 j cap into 10 to the power 6. Solve this. Okay, solve this, you will get F vector is equal to minus, so this is 2 into 2, 4, right? 4 into 2 is 8. So minus 8 k cap. That is force acting on the charged particle is 8 Newton and it is in negative z direction. So the correct option is D. Question number 18. A conducting circular loop of radius r carries a constant current I. Okay. So we have the circular loop, its radius is r and the current passing through the coil is I. It is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. Okay, here it is in a uniform magnetic field B, okay, such that B is perpendicular to the plane of the loop. Okay, B is perpendicular to the plane of the loop. The magnetic force acting on the loop, right? The magnetic force acting on the loop. Here the magnetic force F is equal to mu naught I. Okay, magnetic field due to the loop is equal to mu naught I divided by 2 pi r, right? Mu naught I divided by 2 pi r, isn't it? So it carries a current I, right? It carries a current I. So then it is placed in a uniform magnetic field, right? So this is the magnetic field due to the circular loop at its center, mu naught I divided by 2r. Okay, we need to find magnetic force acting on the loop, right? Magnetic force acting on the loop, F equal to I into L into B, right? I into L into B. L is the length of the wire, that is circumference of the loop. So 2 pi R I into B. So the correct option is B. Okay, 2 pi R 2 pi R I into B. Here B is the external magnetic field. Okay, so this is BC. Yeah. Next question, question number 19. A long solenoid carrying a current produces a magnetic field B along its axis if the number of turns per unit length is tripled. That is, n dash is equal to 3n and the current is halved. I dash is equal to I by 2. Then the new value of the magnetic field will be magnetic field due to the solenoid B equal to mu naught n into I, right? So here B is directly proportional to n and I, right? So now B dash divided by B is equal to mu naught n dash I dash divided by mu naught n into I. So now B dash divided by B is equal to mu naught will get cancelled, n dash is 3n, I dash is I by 2. So n and I will get cancelled. So 3 divided by 2, right? So B dash is equal to 3 by 2B. The correct option is C. Okay, correct option is C. Question number 20. The strength of the magnetic field at a point distant R near a long straight current carrying wire is B. The field at a distance R by 2 will be. Again, the simple one, right? Isn't it? Here, strength of the magnetic field at a point distant R near long straight current carrying wire, right? So what is the magnetic field due to the long straight current carrying wire? That is mu naught I divided by 2 pi R, right? So from this I can conclude that B is inversely proportional to R, right? Current is not changing, so B is inversely proportional to R. So now B dash divided by B is equal to R divided by R dash, right? R divided by R dash. Now R dash is R by 2, right? So B dash is equal to B into R divided by R by 2. So R will get cancelled. B dash is equal to 2B. The correct option is B. So from this I can conclude that as you move towards the straight wire, the long straight wire, the magnetic field increases, right? Yeah. Question number 21. Two galvanometers A and B require 3 milliampere and 5 milliampere respectively to produce the same deflection of 10 divisions. Then the simple one, right? We know that sensitivity of the galvanometer is inversely proportional to the current. Okay, so now SA and SB are the sensitivity of the galvanometer A and B, and current in the first for galvanometer A is 3 milliampere and in B is 5 milliampere. Okay, take the ratio. Okay, so then SA will be greater than SB. Okay, so the correct option is D. Take the ratio, you will get the answer D. Okay, you will get the answer D. Question number 22. A magnetic field B perpendicular to the plane of the paper is present at certain place. Calcium ion Ca2 plus, right, that is 2Q, is moving in the plane of the velocity V. The magnetic force acting on it is. Okay, so we need to find magnetic force acting on the calcium ion, right? That is 2E, right? Here the calcium ion, calcium 2 plus is equal to, here this will be 2E, right? So 2 into E, right? So the magnetic force F equal to Q VB sin theta, theta is 90 degree. Okay, so F equal to 2 times E into V into B. The correct option is B. Okay, yeah. Question number 23. A particle of mass m, charge q and kinetic energy T enters a transverse uniform magnetic field of induction B. After 3 seconds, the kinetic energy of the particle will be. Again, the direct question, right? Kinetic energy of the particle is same, that is T only. Why? Because the speed of the particle does not change, right? Velocity will change, that is the direction of the particle will change, but the speed means the magnitude of the velocity, right? Speed will not change. Okay, so the correct option is A. because kinetic energy is half mv square, speed will not change, right? So therefore kinetic energy will also be same. Question number 24. What uniform magnetic field applied perpendicular to the B of an electron moving at a speed of 1.3 into 10 to the power, moving at a speed of 10 to the power 1.3 into 10 to the power 6 meter per second is required to make the electrons travel in a circular arc of radius 0.35 meter. Again, the simple one, right? So we know that when charged particle enters into the uniform magnetic field perpendicularly, what happens? It takes circular path. So the radius of the circular path r equal to m into v divided by qb. So we need to find the value of b. So m into v divided by qr. So b equal to, what is the value of m? M is the mass of the electron. That is 9.1 into 10 to the power minus 31 kg into v. V is 1.3 into 10 to the power 6 divided by q into r. Q is charge of the electron, that is 1.6 into 10 to the power minus 19 into r. R is 0.35 meter. So now solve this. Okay, solve this. You will get b equal to 2.1 into 10 to the power minus 5 Tesla. So the correct option is C. Question number 25. The graph showing the variation of magnetic field strength B with distance r from long current carrying wire conductor. Okay, current carrying conductor. So this is the long current carrying conductor. Okay. So we need to find variation of the magnetic field with distance r. So what is the magnetic field due to the current carrying long conductor? B is equal to mu naught I divided by 4 pi, here this will be 2 pi r, right? 2 pi r, right? I is constant, mu naught by 2 pi is also constant. So magnetic field is inversely proportional to r. So as you move away from the current carrying long conductor, okay, so what happens? Magnetic field decreases inversely like this. So the correct option is here C. Yeah. Next question, question number 26. Inside a cyclotron, a charged particle is subjected to both an electric field and magnetic field. It gains kinetic energy due to electric field. Okay, not it gains kinetic energy due to electric field. Okay, not due to magnetic field. So due to magnetic field, its velocity changes. Okay, its speed does not change. Okay, its velocity changes. That is, the direction of the motion of the particle changes. Its speed does not change. Okay, due to the electric field, its speed increases. Okay, so the correct option is A, only the electric field. Yeah. Question number 27. A certain length of insulated wire can be bent to form either single circular loop. Okay, the length of the wire is L. Okay, now it is bent into a single circular loop, that is, the length of the circular loop is equal to circumference of that circular loop, right? That is 2 pi r1, or a double circular loop of smaller radius. Okay, so L equal to here 2 pi into r2. R2 is smaller compared to the r1 into 2. How many number of the circular loops are there? 2, right? So 2 pi r2 into 2. When the same steady current is passed through the wire, so current through the first case is same as second case. Okay, the ratio of the magnetic field at the center in case first to that of case second. So B1 divided by B2 we need to find. So magnetic field due to the circular loop at its center is mu naught I divided by 2r, right? So here r is r1 whole divided by mu naught I divided by 2r2. Okay, so what is r2? Here r2 is equal to L divided by 4 pi. R1 is equal to L divided by 2 pi, right? So now B1 divided by B2, substitute the expression of R1 and R2, you will get B1 by B2 is equal to 1 divided by 4. The correct option is D. Okay, correct option is D. Question number 27. A charged particle moves in a uniform magnetic field. The velocity of the particle at some instant makes an acute angle, that is theta, is lesser than 90 degree with the magnetic field. Okay, the direction of the motion of the particle or the velocity of the particle makes an angle, acute angle with the magnetic field, right? The path of the particle will be the simple one, right? Isn't it? So this is how the particle enters. The angle is theta. This is the direction of the magnetic field. Okay. So when particle enters with velocity v, makes an angle theta with the magnetic field, what happens? It takes helical path, right? Helical path. Does the pitch of this helical path is same or different? Here the pitch is same, right? Isn't it? The pitch is same. Okay, because we have applied only a magnetic field. If you applied electric field, what happens? It's here the pitch of the helical path changes, right? Or pitch will increases. Why? Because due to the electric field, the particle will get accelerated, isn't it? So the correct option will be here helix with uniform pitch. Okay, yeah. Question number 29. A proton and an alpha particle are projected with the same kinetic energy. Okay, kinetic energy of the alpha particle is same as kinetic energy of the proton at right angles to the uniform magnetic field. That is, angle between the speed of the particle and or velocity of the particle, angle between the velocity of the alpha particle and proton is perpendicular to the or 90 degree with the magnetic field. The ratio of the radii of their path is, okay, so here we need to find the ratio of the radii of their path, right? When charged particle enters into a uniform magnetic field perpendicular to the uniform magnetic field, what happens? It takes circular path. So radius of the circular path is mv by q into b. So what is mv? Momentum. We know that momentum is equal to root of 2m kinetic energy, right? So r equal to root of 2m kinetic energy divided by qb. Okay. So now the ratio of the radii of the circular path taken by the proton to the alpha particle, that is rp by r alpha, is equal to kinetic energy is same, magnetic field is also same. Okay, so root of mp divided by root of m alpha into q alpha divided by qp. So now rp divided by r alpha is equal to mp root of mp divided by root m alpha. M alpha is 4 times mp, right? 4 times mp. So root of 4 is equal to 2. So root mp will get cancelled. So this will be 1 by 2 into q alpha is 2 times qp, right? So that is qp will get cancelled. It is 2. So 2 will get cancelled. So rp is equal to r alpha. That is, the ratio will be 1:1. The correct option is C. Yeah, and the last one. Two infinite straight wires A and B, 1 meter apart. Okay, two infinite straight wire. Okay, or 1 meter apart, A and B, are carrying currents of I and 4I. Here this is I and 4I, respectively, in same direction. Okay, in the same direction. The distance of the point from the wire A at which the net magnetic field is 0. Okay, so this is the point where net magnetic field is 0. We need to find the distance between the point where the net magnetic field is 0 and the wire A. Let's say this distance is x and this will be 1 minus x, right? So now what is the magnetic field? Okay, what is the direction of the magnetic field at this point? Let's say point is P, is into the plane due to the wire A. Now due to the wire B, the magnetic field at point P is in outward direction, right? So the net magnetic field is 0, right? That is, magnetic field due to the wire A is equal to magnetic field due to the wire B, right? Magnetic field due to the wire A is mu naught I divided by 2 pi into x, right? So which is equal to mu naught 4I divided by 2 pi into x, 1 minus x. So now mu naught I by 2 pi, mu naught I by 2 pi will get cancelled. So now x, 4x, okay, 4x equal to 1 minus x, okay, 4x equal to 1 minus x. So now 5x is equal to 1, so x equal to 0.2. The correct option is A. Okay, yeah, that's it. Thank you so much for watching this video. Okay, so if you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.